Hi guys, for today's video, I am going to teach you how to use Excel Solver and goal seek in solving problems of optimization, root finding, and system of linear equation. So for this example, let's solve using optimization. Let C1 be our cargo 1, C2 be cargo 2, and C3 be cargo 3. And then the objective is to maximize the profit for shipping company, and it is equal to 250 times C1 plus C2 plus C3. And then our decision variable for C1, C2, and C3 is 0, 0, and 0. So for the constraints, weight, volume, amount 1, amount 2, and amount 3. So for the constraint volume, so for the volume of C1, C2, and C3, this must be equal to less than or equal to 100. The volume of C1 is 550. For C2, it is 800 and 400. And it's less than or equal to 50,000. For the amount 1 of C1, we have it must be less than or equal to 30. Then for amount 2, it is less than or equal to 40. And for amount 3, it is less than or equal to 50. Let's put the total here. Total. So, for us to find out the total of our decision variable, so let's type equal sign and then click this one and then enter. So we get 0. And then to solve the total for this constraint, we need to put an equal sign and then open parenthesis 1 multiplied by our decision variable, close parenthesis, and then plus this one plus and click enter. So we get 0, but we cannot drag this like ganito because magmamali siya. So what we're gonna do is to click this and we put a dollar sign in this portion. So shift dollar sign in that one. Then we can now click enter. So we can pwede na natin siyang i-drag. So yan. Our objective is to find the maximum profit. So let's put maximum profit. 31, it's gonna equals to 50. Then let's multiply it by another by our variable. So for this one, we're gonna do to find the maximum profit is to again click this one and let's put the open parenthesis first para hindi magkagulo. And then let's click this close and then plus this one and click enter. So we get 0. So dito na natin ma-apply ang solver. So since naka-solver na ito, what we're gonna do is to change this. We need to set objective. So for this, we need to set our objective as 0, and then by changing the variable, our variable is um this one, and subject to the constraint is for cell reference. Our cell reference is this one, and it must be less than or equal to our constraint, which is ito. And then click OK, and then change it in simplex LP. Click option, and then in seconds you put 100 and 100 for iteration, and then click OK. And then since naka-maximize na siya, so click solve. And then if you want to see the answer, sensitivity, and limits, you can click this and then click OK. So we get 24,218.75. So this is our maximum profit. Let's highlight this, and this is our decision variable. So yeah. So for the answer, we have here sensitivity report and limits report. Ito. That's how we solve optimization problem. So now let's proceed with another problem. Solve the following system equation using solver function. So let's solve this problem, and this problem is an example of a linear equation. So the objective is to, of course, find the root of x, y, and z. So, and we have the decision variable. Let's say this is our x, y, and z. So for the decision variable, let's say our initial condition is at 0 for x, y, and z. And then this is an example of a constraint. So just like the previous problem, then din natin siya isa-solve. So for our x, if we transpose this first equation, yung 2x plus 4y plus 5z minus 33 is equal to 0. If we transpose this negative 33 to the right side, it will become positive. So our equation now will become, let's say, I'll just put string 1. Let me draw this, okay? So for our x constraint 1, we have 2, 4, and 5. So let's put total here, and then equal to 33. And then for constraint 2, we have 6, 6, and 7 equal. And this is positive 70. And for this constraint 3, we have 3, negative 6, and 4 equals. If we transpose this, it will become negative 71. So, how are we gonna solve for the total of this? So just like the previous problem, we need to solve for equal this. So we get 0, and then for this one, you can solve this by using this. So again, 4 times 0 plus 5 times 1, and then click enter. So we get 0. And then, again, we cannot drag it kaagad because mag-change yung ating answer. So, ang gagawin natin is to put yung parang US dollar sign dito sa atin. So, ayan. And then, after that, we can now drag this. We can now use this. We can 0, and then by changing the variable, which is our variable is this one, and then subject to the constraint, the type constraint. So for cell reference, we click this one, and then it must be equal to our constraint is this one. So click OK, and then this is then click solve, and then if you want to see this is our x, y, and z. So we have 6, 11.5, and -5. So in total we have 6. So this is the decision variable. This is how we solve a system equation using solver function. Then the third problem is this one. Okay, this is an example of chemical engineering problem, and we are asked to solve this using goal-seek. So find the specific volume of N-butane at 500 Kelvin and 18 atm using the Redlich-Wong equation of state. So this is the formula for the RKE, for the Redlich-Wong equation. And then, so these are the given. We have the N-butane, and the temperature is given by 500 Kelvin, pressure is 18 atm, and then for the critical temperature, it is given by 425.2 Kelvin, critical pressure is 37.5 atm, and R is given by 0.082061 atm gram mole Kelvin, and A is given by this formula 0.42748 times R raised to 2 times TC raised to 2 over PC times alpha. And for B, it is given by 0.08664 times RTC all over PC. And for alpha, it is given by 1 over TR raised to 0.5. And for TR, or the reduced temperature, is given by T over PC. So this is the formula for this problem, and the required is, of course, the volume using goal seeker. But before we can solve that goal seeker, we need to use the ideal gas equation, where V is equal to RT over P. So for the critical temperature, for R, it is 0.082061 atm over gram mole Kelvin, and by plugging the given R, TC, and PC, then alpha, we get this one. We get 12.79842. The same with B. We need to plug in this equation, this formula, to solve B. So by plugging the formula, we will get this one, 0.080615. And then for alpha, solving. Okay, and then for TR, so we need to plug in. So we'll get 1.175917. Okay, and then after that, what we're gonna do is to solve for B using goal seeker. So using the ideal gas law, we get this. As you can see, RT over P. So our answer for that is 2.279472. And this, take note that this is the initial value of V. So using this formula, okay, let's copy this one. And then using this formula, we need to change. Let's copy here, right here. So let's substitute the given equal, and then let's change our p, where p is given by this one, v is this one, r multiplied by the temperature, which is this one, plus v, where v is equal to this one, and a, our a is this one, p, our p is 80 multiplied by v, b, so b is this one, and then r, so we just need to plug in, and then temperature is at 500 multiplied by v, where b is this one, and then minus a, where a is 12 point something multiplied by b, where b is 0.08 point something, 0.080615. So this is equal to so we get the function of v is equal to 20.33547. So I should put 2.27947. Okay. Let's try to solve using Goal-Seek. So for this one, set cell is this one to a value of 0, and then by changing the cell, is this one. Click OK. So there we have it. Then click OK. So our volume is 2.03717, and the red Kong equation is this one, 0.000163. So this is our final answer for this problem. Let's highlight this one. So yeah, this is how we solve Goal Seeker. Okay, so I think that's it. Thank you for watching, and I hope you learned something from this tutorial video. I'll see you guys on my next vlog. Thank you. Bye.